negative and fractional indices. Let's look at this pattern formed by indices. 3 to the power of 3 means 3 times 3 times 3, which is 27. 3 squared means 3 times 3, which is 9. 3 to the power of 1, you might be able to sort of see for yourself, well, that's just going to be 3. It's just got it on itself. Now, what about 3 to the power of 0, 3 to the power of minus 1, 3 to the power of minus 2? What's going to happen here? Well, look what's happening as we work down this pattern. To get from 27 to 9, we divide by 3. To get from 9 to 3, we divide by 3. So if we keep this pattern going and divide by 3 again, we get that 3 to the power of 0 is actually 1. Now, it doesn't seem to make sense, but 3 to the power of 0 is 1. But what about 3 to the power of minus 1? Well, let's keep going. Let's divide by 3 again. Well, 1 divided by 3, I'm going to write this as a fraction. It's 1 over 3. 1 divided by 3. What about 3 to the minus 2? Let's keep going again. Divide it by 3. Well, if you divide a third by 3, imagine having a cake split into 3, and each of those thirds you split into 3 again, we're going to get a ninth. And one more to get to the 3 to the minus 3, divided by 3 again, it's a 27th. Now some of you may be able to see a pattern already, I'll just highlight it for those who can't. 3 to the power of 3 is 27. 3 to the power of minus 3 is 1 over 27. 3 to the power of 2, 3 squared, is 9, and 3 to the power of minus 2 is 1 over 9. And finally, 3 to the power of 1 is 3, and 3 to the power of minus 1 is 1 over 3. So we can see that a negative power is 1 over the positive power, and we can actually take 3 rules from this table now, what we've done. Any number to the power of 1 is itself, because it just means there's 1 over the number. Any number to the power of 0 is 1. And also, as I said, any negative powers are the same as 1 over the positive power. So let's use that to answer these questions. So 137 to the power of 1. Well, as I said, anything to the power of 1 is itself, 137. B, 67 to the power of 0. Well, anything to the power of 0 is 1. Now C, 5 to the minus 3. Well, let's ignore that minus for a second. We'll do 5 to the power of plus 3. Well, 5 to the power of 3 means 5 times 5 times 5, which is 125, which means 5 to the minus 3 is 1 over 125. And finally D, 2 to the minus 5. Well, let's ignore that minus again. 2 to the power of 5 means 2 times 2 times 2 times 2 times 2, which is 32. So 2 to the minus 5 is 1 over 32. So some slightly different questions now. Write the following as a single power over x. So we're linking it to algebra now. 1 over x to the 4. Well, this is the same as x to the minus 4. Because remember, minus power is 1 over the positive power. So 1 over x to the 4 is the same as x to the minus 4. Similarly, 1 over x to the 6 is the same as x to the minus 6. And we can also have fractional powers. They were negative powers, 0 and 1. What happens when we got fractions? So the power of a half is the same as square root. Now the reason for that being is that a to the power of a half times a to the power of a half, if we use the laws of indices, when we multiply you add, so that'd be a to the power of a half plus a half, which would just be a to the power of 1, which is itself a. So you're timesing something by itself and getting a number, that means it must be the square root of that number. Don't worry too much if that rule's gone over your head on why it is that. All you need to remember is power of a half is the same as square root. And similarly, power of a third is the same as a cube root. So we're going to use that to answer these last few questions. 81 to the power of a half, well that means the square root of 81. Square root of 81, what squared is 81? Well, that's 9. B, 64 to the power of a third. The power of a third means cube root of 64. So what number cubed gives you 64? Well, that's 4. 4 times 4 times 4. And finally C, 27 to the power of a third. Well, third again means cube root. So it's the cube root of 27. What cubed is 27? Well, that's 3.